Hi everyone. We were building SpaceTriage. It's more like AI-guided ultrasound summarization. So Connie came up with the problem of, like astronauts don't have access to medical devices in space. So the most easiest and approachable solution is ultrasound machine, which is pretty small and can fit within the spaceship, I guess. The problem with ultrasound is that it is not very clear and it is very noisy, the images. Uh, so initially we thought of a plan where you can use the ultrasound image and then use a segmentation model to segment small parts of your organs and then have a reasoning model kind of reason over it and summarize what the problem actually is, or is there any problem first of all. So another problem is that uh, astronaut might not have the full knowledge of the human anatomy. So whenever he starts scanning the body, he might be, kind of, mislocating the scanner on your body, and like it might not be capturing the correct organ. So uh, we have here is a demo where you can enter the target organ that you want to diagnose, and you just upload the image of that organ. Uh, yeah. So for example, like we are currently diagnosing liver, and we have this image which we upload. So first thing what happens is we identify if this is a liver or not. If it is a liver, it goes on to like diagnose it and give a summary of what is happening. But in case it is so yeah, like here. So initially we were using SAM2 to segment the liver from that image, but it wasn't working as well as it works with MRI and other kind of images. So we removed that and like we directly are going with GPT-4o for now. But yeah, like if it doesn't, if we are targeting, say, heart, can you put heart over there? And you upload image of a liver, hopefully it misidentifies it. Yeah, so it identifies that it is not a liver, and it asks like, do you want me to help you navigate to the heart for a better view? So you can ask it to guide you. Yes, and it's basically like the scanner is like you can move it across your body. So if it is a live video feed, it can help you navigate the body to reach the correct organ. Now heart and liver are pretty common, so it's fine. But yeah, like say small organs or small muscular parts of your body, and then it gives you steps to navigate from that part to heart. So it may give you like go up or something like that, and then you can upload, like it will have the new image basically in the next step, and then you can see the summary of. But yeah, currently like you will have to upload the image of heart, which we don't have right now. So yeah, uh, and it will give you the summary again. So yeah, that's what we built today. But yeah, like we would like to work on this because the data is not sufficient. Maybe training a small VLM for like the images of uh, ultrasound would be helpful to get better insights. Yeah.
Do you guys benchmark how like GPT-4 performs on this type of data?
Sorry.
If you benchmark the performance of PLM, like does it actually do?
No, we did not benchmark anything yet. We were trying to play around with the segmentation models. So we found a couple of models which are fine-tuned on medical data, but most of that data was MRIs and other kind of, X-rays and stuff like that. There's not much data sets which have properly annotated ultrasound images. So
Did you have an annotated data set? It's for you.
for this one,
Yeah.
like we randomly took these images from some random data set. So
Like,
no.
do you know like how to identify it yourself? Like, can you see a liver?
Can you see a liver?
Can you see a liver?
No, I cannot see anything. There's a heart image wherein the model identifies that it can see four chambers, but it's like very dark. So that's why it's like very hard for small models to do that. I could have a good example. Like, yeah.
Can I comment in? Is that okay? I don't know if anyone can hear me.
Yeah, yeah.
Yes, yes, we can.
Hey, I'm Dr. Fischetti. I'm sorry I can't be there. I just got back from work. But I love this because this is a real life problem. Point of care ultrasound is currently the only diagnostic and therapeutic modality in space. Portable MRIs and X-rays are being developed, but ultrasound is the only one without radiation, which radiation, especially in space, is a big issue too. The one thing that's very difficult, having worked in the AI space specifically within ultrasound, is that ultrasound, unlike MR and CT imaging and X-ray imaging, I mean, there are like thousands, millions of more frames per clip compared to like CT images and MRI images. And so what makes it really hard to create the AI models is because there's, you know, hundreds of frames even within a 6-second clip. And so that's why the annotation can be very difficult and why the models can take so long to train too, because the nuances are so different. And so right then you're showing just a still, what we call like a frame. Actual clip of it would be even more complex to annotate, but something that is, I love what you're starting to propose, because it's a real life problem that we'll have, especially as, you know, we do longer duration missions. Currently, a lot of the astronauts, they rely on telehealth and they rely on just in time cue cards. And so you can imagine that as you go to Mars, that time delay and the lag is really unhelpful when you're trying to diagnose real time with, you know, potentially limited satellite or signal. So this has been a great start. Good job.
Thanks.
Can I ask a question, like to Dr. Fischetti? I'm Connie, by the way. I'm just remote. So for this kind of project, the next thing would be to just think how to. We also found some videos like this kind of from Stanford University from ultrasound. So for this kind of project, would the next steps would be to? Would you recommend like doing more like videos or actually just like still focusing on still images, but improving the training of the models?
I mean, of course, it's going to be easier to train models on still frames rather than video clips. Usually, there are 3 to 6 second video clips. Like you said, it can be very hard to find open access data sets, and you know, I would say that if you are going to do that, you want the same image, right? So maybe just an apical 4 view of like 200 cardiac views. So you can imagine how difficult it is to get that. There are open access data sets, so finding the right ones, I think, will be important. There might be some even within Boston through like the Mass Life Science Challenge. I know that they're creating a data set for something like that. But yes, to answer your question, I think the easiest first step would be to do it really well with clips, or I'm sorry, still frames, and then to evolve into clips, because I think it'll be much more laborious to do the actual, you know, video clips than the frames.
Understood. Thank you.
Yep.
So as you might have noticed, we have a guest, Dr. Fischetti. Thanks for the comments. And actually, I think we have a little bit of the time until we're waiting for research teams to drop their projects. How many more teams we have who are ready to present tonight? So one hand per team, please. 1, 2, 3, 4.